Hey guys, welcome to Mathletics. Today I'm going to talk about integrating factors. Now we use these to solve first order differential equations. Now if we have a first order differential equation of the form dy over dx plus m of x y is equal to n of x, then we can use integrating factors to solve this. Now what is this integrating factor? It is a function which we will use the symbol of mu of x that will help us simplify our differential equation and allow us to solve it with just one simple integration. We will define this as equal to e to the power of the integral m of x dx. How we came up with this? Let's see this with an example. Now suppose you want to solve this dy over dx minus 4y is equal to x. Our first order of business is that we're going to multiply each of these terms by mu of x. So you get mu of x dy over dx minus 4 mu of x y is equal to mu of x times x. Now notice that this entire expression is actually the derivative of mu of x times y. To see this, let's differentiate with respect to x. Mu of x times y. We will use the product rule. So this becomes mu of x times dy over dx plus d mu over dx times y. Now we can see, according to this, there is a similarity that we can see. Right here and here. We have a y here and a y here. Now this tells us that if this relation is true, then this should be equal to this. So then we can equate them. d mu over dx is equal to negative 4 mu of x. These are separable, this equation, and you can use this by separation of variables. If you don't know what that is, you can check out my last video. So we're going to integrate both sides, basically like this. Sorry, we haven't separated the variables yet. So these become d mu over mu of x is equal to negative 4 dx. Now these are separate. Now we can integrate. Integrating these both sides, you get ln of mu of x is equal to negative 4x plus c. Now if you want to get rid of this ln and solve for mu of x, you raise everything over here to the power of e. So you get mu of x is equal to e to the power negative 4x times times c equal to c e to the negative 4x. Basically how we get this c is just e to the power of the small c So this is just some basic algebra. What we're going to do is we're going to let this c equal 1, this constant. We just want to get rid of this c. We're going to play a little bit with these c's here and there. So now that we have our mu, which is mu of x, is equal to e to the negative 4x, we're going to substitute this back right here. Basically, we're going to multiply it by each term. Then you get e to the negative 4x times dy over dx minus 4e to the negative 4x times y is equal to x e to the negative 4x. Now, we had previously said this is equal to the derivative of mu x times y, which is the same as the derivative of e to the negative 4x times y, because mu is negative e to the negative 4x. So, if we substitute this right here, we get d over dx e to the negative 4x times y is equal to x e to the negative 4x. Now we will integrate both sides with respect to x. You get e to the negative 4xy is equal to the integral x e to the negative 4x dx. Notice right here, if I just take the integral of a differential, it's just this expression. Okay, so now this, it can be solved by integration of parts. So if you solve it by integration of parts, you get e to the negative 4xy is equal to negative 1 over 4x e to the negative 4x plus 1 over 4 e to the negative 4x dx. E to the negative 4xy is equal to negative 1 over 4x e to the negative 4x minus 1 over 16 e to the negative 4x plus c. Now we're pretty much done. All we're going to do is divide everything by e to the negative 4x. We just want to make y the subject of this equation. So we get y is equal to negative 1 over 4x minus 1 over 16 plus c e to the 4x. And we're done. Hopefully that made sense. I'm going to give you a shortcut. Not a shortcut, basically an easier way of remembering how to solve this. Okay, yeah, basically a shortcut. So first, you're going to check if equation that you're dealing with is in form of dy over dx plus m of x times y is equal to n of x. 2, you find the integrating factor, which is e to the power m of x dx. This is the same thing that we defined all the way here, and it is also proved by what we found here. We found here that mu of x is equal to e to the power negative 4x. M of x here is negative 4. E to the power, the integral of negative 4 dx, is e to the power negative 4x. So 3 is, write the equation in form mu of xy is equal to the integral mu of x n of x dx. Number 4, you integrate the right-hand side, and 5, you make y the subject of the equation. There you have it. You can take a screenshot of this if you like, or write it down. Now to finish off this video, we'll see another quick example. So say we have dy over dx plus 10y is equal to 4x. Then we said our integrating factor is e to the power mx dx. Mx over here is 10. So 10 dx is equal to e to the power 10x. Next, we write everything in this form. So that becomes mu of x times y, which is e to the power 10x times y is equal to the integral of 4x e to the power 10x. Nx is 4x, and mu of x is e to the 10x. Multiply them both, you have this. Now this can be solved by integration by parts, and you will get 4 over 10 x e to the 10x minus 4 over 10 e to the 10x dx. This is 4 over 10 x e to the 10x minus 4 over 100 e to the 10x plus c. Now, remember this part, we'd multiply mu of x by y, just like this, and we're going to equate it to this. So e to the 10x times y is equal to 4 over 10 x e to the 10x minus 4 over 100 e to the 10x plus c. All we have to do now is divide everything by e to the 10x, and you will get y is equal to 4 over 10 x minus 4 over 100 plus c e to the negative 10x. And that is our final answer. I hope this stuff was all clear for you guys and it helped you in some way, and the examples also helped you. So if it did, please share the video with your friends, and I will see you guys very soon.